Okay, now I'm going to solve a system of linear equations, lines, by method of substitution, where we will have infinite solutions. Okay, now what could that be? Well, here's what it is. Say you have a line here. There's line 1. Okay, well, right over the top of it happens to be line 2. So they're both lying on top of each other, and thus they are the what? Same line. Okay, they're the same line. Well, when you have this, you have infinite points that are all shared together. Okay, where one is living and the other is living at the same time. So you got infinite solutions, and that's what it is. This is the same line. In this case, M1 equals M2. Okay, the slope of line 1 equals slope of line 2, and B1 equals B2. The intercepts are also the same. All right, let's see an example of this case. I have here 3y minus 6x equals 24. And then I have 8 plus 2x equals y. Now, at first glance, that's my system right there, two linear equations. And here I'm going to call this equation 1. I'm going to call this equation 2. Okay. I can't tell at first glance if these are on top of each other, what the slopes are, what the intercepts are. I have no idea at this moment. I am going to run through this by method of substitution. Okay, and I'm going to see what comes out. All right. So I'm going to tell my teacher what I'm doing. I'm substituting E2 into E1. Okay, that's what I'm doing. So let's see what E2 look. Why did I substitute E2 into E1? Well, look, I already have Y isolated over here, so there's no work to do. All I do is take this stuff here, and I'm going to throw it right into the Y. If I chose this equation to start rearranging, then I'd have to solve for one of these variables before I put it. Okay, I'm coming here and showing that we substitute this y in for here because it's already solved for us. All right, so I rewrite my equation 1. Okay, so I rewrote equation 1 right here, and I'm going to dump this y value into the equation 1 y value. So the y value from equation 2 going into 1. I'm not just substituting equation 1 into equation 1 or equation 2 into equation 2. You have to use both equations, and you have to substitute one of the values into the other or alternate equation. Okay, now I'm going to use the principle of distribution to these two. So I have 3 times 8, 24, 3 times 2x, 6x, minus 6x carried down equals 24 carried down. Okay, I draw a line, and I'm going to move over my 24 to collect like terms. I have to move him over, and I have these two here. Well, then we see a nice surprise. We have 6x, okay, minus 6x, and then this side goes away, and that side goes away. So you got 0 equals 0. And you may say, well, what's up with this, but, well, you could just say that it's a true statement. 0 does equal 0. There's no x's in here, and there's no y's in here either. What the significance of this means, where you don't get any x equals 3 or y equals 2 or anything like that, or the other condition where we had one solution, that would be one solution, or we get a statement that's not true, where there would be no solutions, okay? In this case, we get 0 equals 0. Okay, that means you have infinite solutions, It's a consistent system. Okay. Why? Because you have a solution, so it's consistent, but it's dependent. It's not independent. It's dependent. And there's another word they use for this type of system. It's coincident. Okay, so you have a consistent system, dependent and coincident. Infinite amount of solutions because the one line lies on top of the other line. If you like, you can call them the same line, and the slopes are the same, and the intercepts are the same. Okay, this got a little screwed up before with my video, but there you go. That's the end of it.